Now here's the picture, and it's kind of small, and you'll see why in a minute. Because I had it bigger until they came out with a new 1,200% increase, and I had to make this smaller. The picture on the left is infectious diseases going down from 1950 to 2000. Precipitous decline in rheumatic fever, hepatitis A, tuberculosis, measles, and mumps. During the same interval on the right, you see precipitous increases, and the x-axis on the left is up to 100%, the right one is at 400% increases up to in Crohn's disease, which is a gut disease. Multiple sclerosis, type 1 diabetes, and asthma, which, by the way, if you think about it, they all have immune components. And just looking at that, and all of them have this debate that, oh, we just weren't noticing before, including mild, the same thing as we have in autism. The numbers for autism are like that you take the 1,200% number. So we're dealing with something, we really want to get it right, and we don't want to write off an epidemic or even, a piece of wine if something concerning. Any part of this is a real increase and it's a big deal, it's a public health crisis. Now, by some odd coincidence, and this isn't exactly an overlay in terms of time, this is the curve that you see with the increase in the number of new-to-nature chemicals that have been produced over the last 100 years. So this one goes from 1920 to 1980, and you see an exponential rise in things that were manufactured on the basis of work done in laboratories, creating chemicals that to do various things, some of which were directly intended to cause harm to living organisms, such as pests and herbs, like pesticides and herbicides, and chemical warfare agents, and some of which weren't designed for that, but they have problems anyway. Some of the geneticists have said, well, environment's too complicated anyhow, what's changed? This has changed like more than you can possibly imagine. More than I think that most of us can deal with wrapping our heads around. So another thing that has led people to say that autism is all genetic, and among the people who really believe that this is purely or predominantly genetic, these are some of the people who have the hardest time taking seriously that a diet could have anything to do with helping someone with autism. Why? Because they assume the gene affects the brain, and that's the end of the story, and what are you doing with the gut? It has nothing to do with it. So first of all, why do these people think that it's all genetic? Well, two reasons. One of them is people have noticed that in families with autism, there's a higher likelihood of subsequent children being born with autism. And the other one is that in twins, if one twin has autism and they're identical twins, there's a very high likelihood that the second child will have autism or features of it. Whereas in fraternal twins, where they don't share the same genes, the likelihood is much lower. So let's examine that. I don't think I'm so old. I'll just read that to you. I'm sorry that the slides got out of control. So let's just talk about the twin thing. So first of all, people go around and say that there's a 90% concordance, so that if one identical twin has autism, the other will. That's actually inaccurate. If one identical twin has autism, there's a 90% chance that the other twin will have some features of autism. For the other twin to have full autism, there's only a 60% chance, which is still huge, but it's not 90%. Recent studies have been showing that the fraternal twins have concordances much higher than 0 to 10%, up to 35 or more percent. So what is that about? That is that something may be going on that's shared. But the thing that I think is most extraordinary is a little known study from 1995, and it wasn't even in autism, it was from schizophrenia, looking at twins. So here what they did was they took twins, all of them were identical, so each twin pair shared genes. Now you can still have mutations in the germline during pregnancy, so it isn't a guarantee that the twins are identical. But they divided them up into two groups. In one group, both twins had the same placenta during pregnancy, and in the other group they had different placentas. So in the group with the same genes and the same placenta, so one placenta for both twins, there was a 60% concordance. If one had schizophrenia, the other had schizophrenia. In the group with the same genes but different placentas, was only 10.7%. So that's not genes, because they all have the same genes. So something else is going on. That's environment. It's the in utero environment The people who wrote the books, the article said that it's probably infection. I could see a lot of things. I could see blood perfusion issues. I could see positional issues. I could see a lot of things. But the bottom line is it's not genetic, because they already established these people have the same genes. So if they have the same genes and they're coming out only 10% having the same thing, it's got to be. That basically says to any research program in any disorder that you cannot use this concordance data to make it an assumption that this is 100% genetic. I put that to people about 3 weeks ago who funded genetics research to the tune of tens of millions of dollars. And one of them got very indignant. Well, what do you do with the 8? And I said, they have the same genes. They don't have, you know. We assume that it has to be, well, the 80% could be genetic, but it also could be the environmental piece that they share. And the pie chart on the left is the idea that if it's genetic and it's 80%, then that only leaves 20% for the environment. And that makes the assumption that it's either or, and that it has to add up to 100%. But actually that's not true. If you look at good epidemiology textbooks, you find that it's really more like that Venn diagram. You can have 80% genes and 80% environment. It doesn't have to add up to 100%. That's just nonsense. So what we have is millions and millions and millions of dollars spent on a research program that was based on these assumptions, which aren't even true assumptions. So that's pretty sobering. This was a study, and embarrassingly, it was done by a public interest group rather than independent scientists. And why I say it's embarrassing, it's not embarrassing for the public interest group, it's embarrassing for everybody else who didn't get around to doing the study, which is to look at what are the chemicals in cord blood of newborn babies. If we have all the stuff in the environment, that huge, thousands and thousands of chemicals, where is it? So they took cord blood and they looked for 455 chemicals. It cost $10,000 a baby. This is one of the reasons it's not available clinically. It's extremely expensive. They found on an average, 287 chemicals detected. 180 of them are known to be associated with causing cancer. Not necessarily at these doses, but 217 were known to be toxic to the nervous system and the brain. 208 caused birth defects or abnormal development, and really creepy is nearly 200 have been banned from the market for years, and they're still floating around in our babies during pregnancy, because that's how you get into cord blood. So it's interestingly the same people who funded all of that genetics research that I was talking about are going to have a small private meeting soon about chemicals and epigenetics. So what's epigenetics? That's turning genes on and off, and it's becoming clearer that even small quantities of environmental chemicals, among other things, can turn your genes on and off. So you don't even have to have a mutation. All you have to have is a change in which genes are doing what, at which time, and in which part of the body, which can be accomplished by environmental agents. And to have this many things floating around is like an engraved invitation for there to be epigenetic problems. And this isn't the only problem, but this is where we come from. And if you think you can move out of here and go somewhere else where it's not like this, think of the Eskimos, who are extremely toxic right now, and they aren't near the sources of these substances. The stuff blows all over the place, gets in the water, gets in there. They eat a lot of, sea mammals, and the sea mammals, if you have a dolphin that washes up on the beach, it's toxic, and the reason it washed up is that it's too toxic to have it. Probably, I had a researcher approach me to work with me to scan brains of dolphins, and I have the slide that is in this presentation. A third of the dolphins that he scanned that washed up on the beaches on the Cape had brain abscesses and high levels of toxics that are just heartbreaking.